Welcome to this deep dive. We are diving into a discovery that has, well, astronomers buzzing.
It's a big one.
A really big one. The oldest black hole merger ever observed.
When the universe was just a baby.
Yeah, like seriously, just a baby. And we're talking about a time period that's almost unimaginable. We're going to unpack this amazing discovery and talk about what it means for our understanding of, well, everything.
It's pretty exciting stuff.
So to kick things off, can you set the scene for us? Just how old is this black hole merger?
So we're talking about a black hole merger that happened, get this, a mere 740 million years after the Big Bang.
Okay, so to put that into perspective, for those of us who don't have a PhD in cosmology.
Right, of course.
The universe, as we know it, is roughly 13.8 billion years old.
About that, yeah.
So this discovery, it's like finding a baby picture of the universe, like right after it was born.
Yeah, pretty much. It's giving us this incredible glimpse into a period of time that we know very little about.
Now, before we get too far ahead of ourselves, we need to answer a pretty fundamental question here. What exactly is a black hole merger?
Okay, so picture this. You've got two black holes, these incredibly dense objects, right?
Right.
Formed from the collapse of massive stars. Now their gravity is so strong, and I mean really strong, that absolutely nothing, not even light, can escape.
It's like the ultimate vacuum cleaner.
Exactly. So now imagine these two behemoths locked in this gravitational dance.
Okay, I'm picturing it.
Spiraling closer and closer until they finally collide with unbelievable force and merge into one even more massive black hole.
Okay, so that sounds pretty intense.
It is. And this collision releases an absolutely insane amount of energy. And we're talking energy that travels across the universe in the form of gravitational waves. These are literally ripples in the fabric of space-time.
Okay, gravitational waves. I think we need to break that down a little bit because honestly, it sounds like something straight out of science fiction.
It does, doesn't it? But it's very real. Imagine space-time as a giant trampoline, like one of those big ones you'd find at a, trampoline park.
I can picture it.
So you put an object on this trampoline, let's say a bowling ball, it's going to create a dip in the fabric, right?
Right.
Now, put another bowling ball nearby. They're going to both move towards each other because of those dips they create in the trampoline surface.
Gravity.
Exactly. Now, imagine those bowling balls are massive black holes. Like millions, even billions of times the mass of our sun.
Wow.
And they're spiraling towards each other at incredible speeds. This movement sends out ripples across the fabric of that trampoline, space-time, and those are gravitational waves.
Okay, I kind of get it now. So these waves, they travel at the speed of light, carrying information about the objects that created them.
Precisely, like cosmic messengers.
Okay, so back to our record-breaking merger. This isn't just some cosmic fender bender we're talking about. This is like rewriting the textbooks on the early universe, right?
You got it. For a long time, we thought black holes in the early universe, they grew mainly by just pulling in gas and dust, like a cosmic vacuum cleaner.
Right, makes sense.
But this discovery, this suggests that these mergers, these collisions, they might have played a much bigger role in how these cosmic giants actually grew.
So it changes how we understand the entire process.
It could. And it's not just about how black holes grow, it's about how galaxies, how structures formed in the early universe.
Wow. Okay, so tell me more about this incredible system where this ancient merger took place. It has a name, right?
It does. Astronomers have dubbed it ZS7.
ZS7. And it's incredibly far away, right?
It is. ZS7 is about 15 billion light years away from Earth.
Okay, 15 billion. That means the light we're seeing from it now, it started its journey towards us 15 billion years ago, back when the universe was just a baby. And ZS7 is home to two galaxies, each with a supermassive black hole at its center.
These aren't your average, everyday black holes, though. We're talking millions, maybe even billions of times the mass of our own sun.
So these are like the heavyweights of the black hole world.
Absolutely. And what's really fascinating is that scientists detected this hot, fast-moving gas swirling around these black holes.
Hot gas. What does that tell us?
Well, it's a dead giveaway, a smoking gun, that a merger is either about to happen or has very recently happened. Think of it as the after effects of a cosmic collision.
I see. So the question is, how did we even manage to see something so incredibly far away, so far back in time? I mean, that's like trying to find a needle in a cosmic haystack.
You're right. It's a monumental task. And this is where the James Webb Space Telescope comes into play.
Of course, our trusty cosmic time machine.
Exactly. With its incredible infrared vision, JWST can actually see through those vast clouds of dust and gas that usually obscure our view of the early universe.
So, like, it has X-ray vision, but for space.
You could say that. It's allowing us to peer back in time, to witness events that would otherwise be completely invisible to us.
So this discovery, it's not just about breaking records.
Right.
This has huge implications for how we understand the universe and how it's evolved.
Absolutely. For one thing, this discovery, it forces us to rethink our existing models of how black holes grow, particularly in the early universe.
And it's going to change how we look for gravitational waves, right?
Definitely.
Yeah.
It means there could be a whole symphony of these gravitational waves out there from the early universe that we just haven't detected yet.
So what's next? I mean, if we can detect a black hole merger from when the universe was still in its infancy, what other mind-blowing events are out there just waiting to be discovered?
That's the exciting part. Every time we make a discovery like this, it opens up more questions than it answers. But that's how science works, isn't it?
That's the beauty of it. The universe is this vast, mysterious place, and we're only just beginning to scratch the surface.
Exactly. And with tools like the James Webb Space Telescope, who knows what we'll uncover next?
Well, I, for one, can't wait to find out. This deep dive has been a wild ride through time and space, from black holes to gravitational waves to the very edge of the observable universe. Thanks so much for taking us on this incredible journey.
You're welcome. Happy to be here.
And for everyone listening, keep looking up at the stars, and who knows what wonders you might discover.